Hi guys, welcome to my data and data flow episode in my advanced programming series. Today we're going to be going over these red blocks right here, which are a little more complicated than what you might have been introduced to before. Let's look at this first thing. It's called a variable. Now if you're unfamiliar with programming or unfamiliar with computers in general, you may not know what a variable is. A variable is just anything that holds a value. So let's look at it a second. Up here we have the name, and I just named this variable foo2. It can be named anything. I could name it Josh. It doesn't matter. You can name it whatever you want. That's just the name. That's how you keep track of the variable. And then over here we have read and write. If we wanted to find out what a variable is, we would read from it. So let's say we told a variable that it was worth 5, and I'll get more into that in a second. Let's say our variable had a value of 5. We could read that numeric value like so. Or you could write. So let's say I wanted a numeric variable. So a variable can either be text, a string of letters like hello, my name is Josh, or hello world, or really anything. It could be a number like 1, 2, 3, 4, 5, 6, 7.5, any number. It could be logic, true or false. That's the only thing it can be, true or false. It could be a numeric array, which means it's just a bunch of numbers. So instead of only being able to hold one number at a time, like 7, it could hold as many numbers as you want. It could hold 1,300 numbers. Doesn't matter. Or you could have a logic array, which is like a numeric array, except it holds true falses. That's it. So let's define a numeric variable, something that holds a number. And let's say we want to give it a value of 9. It doesn't matter. But then what can we do with that variable? Well, let's say we want to change the motor power of something. See how this has a sort of rounded top, much like this rounded top? That means that it takes a number as a variable. But we can't, we've taken this space to define the variable. Now we have to go back and find the variable again, Josh, and now we want to read from it. We want to see what it says. So we take the numeric value of Josh. Right here we've defined it as 9, and over here we can pull it over here. And now the power of that motor will be equal to whatever the value of Josh is, and in this case it's 9. So if I was to change this to 76, then when I run this, the motor will run with the power of 76. Make sense? So whenever you see a rounded top variable like this, it means a number. But sometimes you'll see something like this that has a pointy top. And if you have a pointy top, that means it's a true false. It means it's not a number, but a value. So let's make a new variable here. Let's make it a logic variable, and we'll call it log. And we'll set it equal to true. So now our variable log is equal to true. Now we can drag it back out here again. We can read from it the logic of log, and we can drag that over here. And so now this value a here is equal to whatever log is. And so we can change log over here, and now it's false, and now we would read it as false. True, and now we would read it as true. So now let's look at these operators a second. So this just gives an output of a logic. So we feed it either true, 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 false, or false, false, one of those, and then it makes a determination. So here's and, or, zor, or not. And means that if both of these variables are true or both of them are false, basically if both of them are true, then have this equal to true. So if we wanted to, let's make a variable over here. Let's use our old variable. We'll write the logic variable log. So let's say if a and b are both true, that's what this and means. If a and b are both true, then log will equal true. If either a or b is not true, then log will equal false. Does that make sense? And means that this and this must be equal to true for this to equal true. Or it's kind of the opposite, or not the opposite, but it means that if either A or B is true, this will equal true. So if A is true and B is true, it will equal true. If A is true and B is false, it will equal true. If A is false and B is true, it will equal true. Only one of them has to be equal to true. Then there's XOR, which means that it will give true if both of them are false. So if A is false and B is false, it will put this as true. It's kind of the opposite of OR. It's kind of the opposite of AND. So both of them have to be false for this to be equal to true. If either one of them are true, this will be equal to false. And then there's NOT. And that's just if A is not true, if A is false, set this equal to true. If A is true, set this equal to false. That's all it does. It just reverses whatever this is. So since A right now is false, this will be equal to true. Now we have, that was for logic, but we also have the similar ones for math. So let's say we had two variables. Let's bring our variables back out here. Foo and Josh. And we want to read them numerically. Sorry, I clicked the wrong button there. Read them numerically. Now we can plug them in to this numeric operator. And so now this operator can do several functions. It can add them together and then give you what that equals. It can subtract them, divide them, multiply them, give the absolute value of 1, take the square root of 1, and then exponent. It can do more advanced stuff, but that's a little more advanced. Basically, it will take these two numbers, these two numeric variables, do something to them, add them together, and then give an output. So then we can have another variable over here that equals this output, like hi, something like that. And so in this particular case, foo2, which is A in this point, plus, because we have plus right here, Josh, which is plugged into B over here, will equal hi. So if foo equals 2 and Josh equals 3, 2 plus 3 equals 5. Hi will be equal to 5. That's it for this episode. I'll get into a little more next, but keep watching and keep creating.